Hello, this video is about Huffman coding. Huffman coding is an algorithm that was developed by a man by the name of Huffman in a term paper as a graduate student at MIT. He wrote it in 1951. So this is used for data compression to figure out how the fewest number of bits to make to represent a piece of data, and the more data, the higher number of bits will be used. So this takes a forest of single branch trees. We're only going to use 6 here pieces of data. There could even be more than one branch, but we're only using one branch here. Depends on what kind of data you're trying to compress. So let's pretend these are minutes of music, and trying to figure out the smallest number of bits to use to represent each of these numbers. So we're going to take the two smallest, and we're going to combine them into one tree, and that's going to produce a tree with, on the right is the bigger value, and the left is the smaller value. We have 0 on the left and 0 on the right. Together, if you were to combine the sum of their two values, it's going to become the value of that new tree. So it's going to create a tree with value of 3, with on its left 2, on its right a 1. Got a 4, a 5, an 8, and a 9 still. Now we're going to combine two smalls again, which is 3 and 4, becomes 7. So you've got 5 and 7 has the bigger value is 4. So on the right here, you have 4. On the left, you're going to have your 2 and your 1. So then you've got also still an 8 and a 9. Now combine the 5 and the 7, they're the two smallest. It's going to make a value of 12. So you've got 8, 9, 12. Now, bigger value is a 7, smaller value is a 5. So 5 gets on the smaller side, 7. It's on the bigger side. And 7 has a 4, and then here this is 3, which becomes the 2, and the 1. Now then, we're going to go over to this side and combine the 8 and the 9. That makes 17. So you have 12 tree, which is 4, 2, and 1. Over here you have your 5. Now this is 17. That's the bigger value, 8 is a smaller value. Now you're going to combine these two together into the final tree. That's going to make 29. You've got 29. So the bigger value is a 17, put on this side. The 9 and an 8. 29. The bigger value is a 12. Small value is a 12. It's all here. Got a 0, 1. 1 is the 5. On the 0, branches off. 0, 1. Got the 4. The 1 branches off. 0, 1. 2, 1. That's all the values that we have here. So now we're going to go over to here, and we're going to put, let's review what numbers we have. We have 1, 2, 4, 5, 8, and 9. 6 values. The 1 is going to represent, it's down here. We have 1, 0, 1, 1. 1, 0, 1, 1. Then the number 2 is represented by 1, 0, 1, 0. 1, 0, 1, 0. The 4 will be represented by 1, 0, 0. 1, 0, 0. And because the biggest ones are 4 bits, we put 0 to make that. 5 will be represented by 1, 1. So you have to write that 0, 0, 1, 1. Because if we're doing this in 4, try to see how the fewest number of bits. So let's take off the extra zeros. Just write it here so it's easier to see. 1, 1. The 8 is represented by 0, 1. And 9, 0, 0. That's the smallest number of bits that can represent these different numbers in this order, in this set right here. If you have a different set, then the numbers will be different. And the bigger the set and the smaller the number, the smallest number is going to have the biggest number of biggest binary number that you can get from that value, those values. And it's going to, the largest value is always going to be the most amount of zeros, because it's always going to be the biggest. And that is Huffman coding.